Let's solve another sum on matrix multiplication. We've been given a matrix here in yellow. It's 2, 1, minus 3, 4 into a matrix X, an unknown matrix X. And the product of these two matrices is equal to 7, 6. Right? We need to write the order of the matrix X and the matrix X. All right. Now, the way we solve a sum like this is, first we need to figure out what is the order of matrix X. Right? So let's just consider the matrix given to us here in yellow as let's say that is matrix A, and as you can see, it's a 2 by 2 matrix. It's 2 rows and 2 columns. So you can write it as a 2 by 2 matrix, right? We are multiplying that by a matrix X whose order is unknown to us. So let us take it to be m by n, right? So m rows and n columns for now. M rows and n columns, right? And on multiplying these two matrices, we get this matrix here. Let's take that to be matrix. That's not the color. Let's take that to be a matrix B, suppose, right? Let's consider this matrix as a matrix B, and as you can see, the order of this matrix is 2 rows and 1 column, so it's a 2 by 1 matrix, right? Now, how do I first figure out the order of matrix X? The thing that you need to notice is, first of all, matrix multiplication is only possible if the number of columns in the first matrix is equal to the number of rows in the second. So here you see these two values must match, which would give me that the value of m is 2. Second, our final product matrix, the number of rows in the product matrix is the same as the number of rows in the first matrix, which we see does match, yeah, 2 and 2. And the number of columns in the product matrix should be the same as the number of columns in the second matrix, right? So that would mean that n over here should be equal to 1. So this gives us the idea that the order of matrix X, right? Order of matrix X, and our matrix X over here is equal to, as you can see, m should be equal to 2, so, right, and n should be equal to 1, so the order of matrix X is 2 by 1, and that's our first answer that we needed to find. Moving on to the second part, we want to find the value of this matrix X, and now since we know the order of matrix X, right, we can assume a value for X. We can say let matrix X, right, be equal to, since we know it's a 2 row 1 column or a 2 by 1 matrix, let's assume this to be the matrix. Let's take the elements as A and B, right? We'll have to assume the elements as A and B, and then solve this matrix further, and then solve this equation that is given to us and find the values of A and B, right? So now let matrix X be equal to AB as such. Let's use the given equation to us, which is 2, 1, minus 3, 4, right? Which is 2, 1, minus 3, 4. That's the given matrix for us, into the matrix A, onto the matrix X, which we've taken as A and B, right, into the matrix X, which is A and B. This is equal to what they've given to us as 7 and 6, right? This is equal to 7, 6, right? This is what they've given us over here in the question. All we've done is we've substituted these values for X and Y, and we've got the answer. So what we need to do now is solve this equation here, multiply these two matrices, and get equations in A and B and solve them. So again, we are multiplying matrices. So first one, as you see, is a 2 by 2 matrix. Second one is a 2 by 1 matrix. Remember, we consider the rows of the first matrix and the columns of the second. So let's just mark them out for the sake of simplicity. First matrix, let's mark out the rows. This here is the first row of the first matrix. This here is the second row of the first matrix. The second matrix is just one single row. So here you go, one single row, marked it out. Let's perform our matrix multiplications. You start off by multiplying the first row, first column. So first row and first column, or rather first row and only column, to get the first row, first column element. So if I multiply these two here, 2 into A and 1 into B, so this will give me 2A plus 1B, right? So matrix I'm multiplying here. Now this is the first row, and that's it. That's all we have. Now we'll move on to the second row. For the second row, we are multiplying the second row and the column over here. So it's minus 3A plus 4B. So we have minus 3A plus 4 into B. So 4B. Alright. This completes our matrix multiplication on the left hand side. This is equal to, let's see what we have on the other side. We have 7 and 6. Right? On the other side we have 7 and 6. Right? So as you can notice, we've got two equal matrices. This can be solved by using the concept of equality of matrices. That means the matrices are equal element wise. Here we have just two elements to deal with, makes our jobs a lot more easier. We can see the first element here, 2A plus 1B is equal to 7. That will be my first equation. And the second element that's matching here is minus 3A plus 4B is equal to 6. That's my second equation. Two equations, two unknowns, are easy enough to solve a pair of simultaneous linear equations. This is equal to 7. This is my first equation. And minus 3A plus 4B equal to 6 is my second equation. And now how do I solve these two? Make sure that the variables match. So suppose I multiply equation number, what I'll do is I'll multiply equation number 1 by 4, right? And then from that I will subtract equation number 2. Right? You can solve it in any way you find comfortable. I'll just solve it this way. So equation number 1 multiplied by 4 will give me 8A plus 4B equal to 28. And alright, let me just, and then equation number, and from that I'm going to subtract equation number 2, which is minus 3A plus 4B is equal to 6. Right. Now when you subtract these two equations, remember the signs in the bottom one will change. So this becomes plus, this positive becomes negative, this positive becomes negative. 8A plus 3A will give me 11A, and 28 minus 6 will give me 22. Right. This tells me A is equal to 2. Okay, so further on, if I am to substitute this value of A, and let's substitute A is equal to 2 in equation number 1, what I'll end up with is 2 times 2 plus 1B equal to 7. 2 times 2 is 4. 4, it's plus 4 here, take it to the other side, becomes minus 4. So B will be equal to 3. Right. So I finally found the values of A and B, which would mean matrix X is equal to 2, 3. This is what we need to find. Right, now let's just write our final answer once again. We've got two things here we need to write. First answer that we need to write was the order of matrix X. So the order of matrix X and is equal to 2 by 1. It's a 2 by 1 matrix. And finally, even the fact that we have to find matrix X as well, that's our second answer that we need to find. Matrix X is equal to 2, 3. This is our matrix X. So this here is our final answer. Let's just mark it as such. So this, if you notice, is our final answer.